integration by parts. This one you need more practice. And again, I write in this style. I'm just writing this so that you can understand, have a full understanding. If I have this, u dv is uv minus v du. Or I can write something like this. This thing is dv. Why? Because v prime is dv dx. So v prime is what? dv is v prime dx. This is v prime dx. This is dv. So these two are the same thing. The hard part in integration by part is you need to tell which is u, which is v. That's the hard part. So for this example, and then let me call it u, okay, and let me call this v. Why? Because of this. Because I know dex is ex. So dex is ex dx. So this thing is what? Ex is my v prime. It just happened, this function, ex, differentiation after differentiation itself. So it just happened, this v prime is v. Okay? For those who didn't learn calculus in the past, please do this. Make sure you really clear about all this step before you jump step. What people do in this, for those who have experience, they directly go here. But please do this, otherwise you get lost. Okay? Then you have this and this what? Then dv is this. I just written down here previously. And what's du? Du is just dx because u is x. Okay? So I have these two terms. Then what? I just put it here. This is my problem. This is the formula. Then I just write here. What's u? U is x, so this is u. What is this? ex dx is dv. So I have dv. Now I put this in u times v. So u times v, u times v, subtract v du. V du. V du. I integrate this. It's just ex plus c. Okay, of course. Then you have this and this. Done. Yeah, so this is how you integrate this. So this is another example. I have an x sine x dx. You can say u is x. And here the tricky part. V is negative cosine. Oh my gosh, why? Because if my v is negative cosine, then d dx is the same, right? D cosine is sine, but you have a negative sign. So negative and this negative cancel out, so you have a positive. So therefore, dv is this thing, dx. This is the hard part. Finding the uv is the hard part in the by parts. Okay, so you have v with this, then therefore, sine x dx is dv. And this thing become x is u, so this is what? V prime dx. So this is the second formula. uv minus what? U prime v dx. So uv, okay? And then what? U prime, u is x, so after prime nothing. And then v dx is here, okay? So you get this, that's it. And what about, okay, this one is same. Let's what else? D log x. So you can actually think of this, but my v prime is 1. Nobody said this one cannot be 1, right? Then here, let me put it here, u dv equal uv minus duv. One small thing is because so many uv, vu is very likely in exam, you suddenly write too fast and then you write this symbol and then you don't know which is which, then therefore be careful. Then I have this. So that means what? Okay, 3v is x. So I have this, and then this what? X, right? V is x. And then du is d log this guy. Then d log x dx is 1 over x. And this 1 over x cancel with this x, so you have nothing. After you integrate, you give v back an x, and you get this. And how do you verify this is true? You differentiate this guy, see whether or not it give you the thing inside. Yes, it d this guy gone. D this guy, what? Product rule. D this is d the first guy, constant. D the second guy. D the second guy is 1 over x. Combined with x is what? Number. 1. We don't care. And then this one, d this is 1. You have log x. The number will cancel with the previous number. So done. So that's the idea. This one is what I just said. You need to know partial fraction. So here are the practice of partial fraction. So what's the partial fraction? So this is for what? Integration. Suppose you want to integrate this guy. You don't know. So the idea is you integrate like this. Then if you want to integrate like this, the first thing to do is you need to know to find this question mark. You write as AB. And then you multiply the whole expression by the denominator. Then here, the denominator and the denominator chop their both heads off, so you have 1. And here, you chop part of the head, this part chop another part of the head, okay, now you have this expression. This is true for any value. Then you just randomly plug some value. I put 1, why? Because if I put 1, this term disappears, so I have an expression here, so it can be a negative 1. And then I put half, so this term disappears, I have this, so give me b2. That's the idea. Same here, and same here, okay? And if you have power term, the idea is, how many bracket here? You make how many bracket term here? So this guy have 2 bracket. So you have 2 terms. This guy looks like have 1 bracket. No, there's a power. So you need to have power 1 and power 2. If this is power 7, then you have power 1, power 2, power 3 up to power 7. And then you have A, B, C, D, E, F, G, and so on. Okay? So this is the technique. Let me recap. You need to know the basic formula. So it's for what? This kind of thing. And then you need to know there's a special case. When this is -1, you have the log x. And log x, technically speaking, is not this. You split two parts, left and right doesn't need to be the same. Okay, this is the formula. And this formula also include, let's say, this kind of thing, sine x, cosine x. These are standard. And second is called substitution. So, okay, sub basically is simplify this guy, then you also simplify this guy. So this is substitution. And then by parts, it's like chain rule in inverse. So if I have this, then I have this. This is like chain rule but opposite. And lastly, this is a new thing. Classically, when you see this kind of thing with a square root or a plus, if you see this kind of thing, you need to think of this, okay? And then you have a tangent, and then you have a cosecant square, okay, that kind of thing. And then you need to use a bunch of trigonometric formula. This is a classical way of doing this. Now I said, screw it, this is the best. So with this Euler formula, cosine theta is ei theta plus e negative I theta divided by 2. Sine theta is what? ei theta minus e negative I theta divided by 2i. This actually is the real part of the ei theta. This actually is the imaginary part of ei theta. Okay? Then you have this. You now convert everything related to sine cosine to ei. And then you do it by method 1. A bunch of polynomials. And after you finish all the thing, go back to your original sine cosine thing. That's it. Because you know, if you know sine cosine, you know tangent, secant, cosecant. Because everybody is just these two guys. If you have a sine, you usually here with I, then you can put the I here. Then you need a negative because you are doing I. So this becomes -1. If you don't have a sine, you only have cosine, then of course you don't have an I here. Then you create I by yourself. In the end, then you have I outside, and then this becomes the EIX, and then you keep going. And there are even more tricks, okay, which the focus of this module is not about trick, it's about understanding. What about the other trick? I just let you know. What are the other trick? So the other trick is, these are the other trick. I just let you know there are other trick. For example, sometimes this actually is what people will do. Nobody actually will do the complex number substitution, nobody will do the sine cosine substitution. They know this is a circle. Then if you know this is a circle, then you will use the geometry. And then sometimes you will use the property called even odd. That means suppose I have something integration like this, then integration this part and integration on the other part is the same, just a negative sign, then I can make use of that. Okay, and you can also have something called T substitution and reduction formula, which nobody care, okay? T substitution means due to some reason, you let x is half theta. And then you do some very crazy sine cosine formula, and then you can solve some very crazy sine cosine equation. But I will say, screw it, ei theta all the way. Okay, reduction formula, screw it, ei theta all the way.